Hi, this is Karthik, a data science master student studying in Cardiff Met University. Today, I'm going to give an overview of the predictive neural network which I developed as part of my project for the module programming for data analysis. Now, the idea here was to collect human activity data from smartphones using an application called MATLAB. So MATLAB captures various sensor data in mobile phones, and we record them as we go about our daily activity. So the activities which I chose were walking, jogging, and jumping, and these activities were recorded in stages. It was not a continuous recording, so you can see multiple files here, and these files were those MATLAB files were converted into Excel files so that we can use it in a Jupyter notebook when we develop our model. So the first step in developing the predictive model is to look at the data and to get a feel of what we have to do and how we have to process it. So you can see here that, for example, first few and the last few data points have to be discarded because they are skewed or they are not similar to the rest of the data. Why? Because these represent the time it takes for a person to click on the record button, put it inside their pocket, or take the phone out of their pocket to stop the recording. So things like these are what we look for when we're visualizing the data. So here we consolidate our data into a single data frame. So as I told, data was collected in a staggered manner, and we have to consolidate all those separate files into a single file. So the first layer of consolidation was done based on the data. So I created 3 data frames for each activity to look at how the data is. You can see that there are no null values here. We look at the count of data. So because I wanted a uniform count of data for all activities, I took an equal number of data and then consolidated into a single data frame called full DF here. And then with other plots like histograms and box plots, it was seen that it wasn't possible to really do a feature selection here because no variable seems redundant. For example, let's take orientation Y. The ranges are different for each activity, but there are overlaps here, which say that because there is no complete overlap, we'll have to consider every data point. Next, histograms, they say the same thing. We also have 3D scatter plots. Here you can see them differentiated by the activities. You can see that the colors here, nothing completely overlaps the other. It might seem that it overlaps here, but if we rotate the axis, it won't. So here it's a line graph showing the activity. You can see how the values change with regards to the record number or the index. So once we do this preliminary pre-processing, we save the data frame to be used further. Now, the first model which we're going to develop is an artificial neural network. Before we input the data, we're going to convert it into NumPy arrays and also one-hot encode the output column. First, I did a trial run. This is the confusion matrix. Only the diagonal shows true value, so this is not a really good prediction. So then I tune the parameters step by step, 1 or 2 parameters at a time, because of the lack of computing resources. It's not the best way to do best way to optimize a network, but something is better than nothing. So this is the only possible way we could do it. So once I parameterized epoch, batch size, optimizer, and the number of nodes in the hidden layer. So this was the learning curve I got. Again, this is not very good learning. This is not a very good learning. It shows that um, it is an overfit curve, and also you can see the noise in the validation dataset, which could be due to batch size, or um, we could deal with that by increasing the batch size, because it's a well-known problem when using low batch sizes. In this case, the batch size was just 32, which is what the optimization portion told us. So next step is again to improve this optimized model we got. I did several trials, randomly picking and choosing and trying to get the best fit. And out of all the trials I did, in my trial 2, this was the best fit I could get, because of the time constraint and the resource constraint. I really couldn't do an exhaustive uh, optimization, but with this, so trial 2, the model used in trial 2 was taken as the finalized model, and then when we did the prediction in that, you can see that the performance is massively improved. Looking at the metrics again, these are very good values. Log loss is very low, whereas accuracy is high. Now, to compare and contrast this simple neural network to a deep neural network, I also implemented a model which was a convoluted neural network model, which was from a research paper. And so with this model, the first thing I had to do was to remove some of the input variables, because they only use 6 input variables. And when I couldn't completely mimic their model, but this was pretty close to what they had done. And when I ran the model and fit it, it was really terrible for my data set. So what I did was, again, I randomly tuned this model, and this was the best I could improve the CNN, and I ran prediction on that. And well, this is not bad either, but this is just a step to compare, is a simple predictive model better than a really deep neural network? And in my case, it was. You can see that the accuracy is low, and the log loss, which has to be low, is higher than what we had in the simpler model which we saw earlier. So this is the overview of my project. Thank you.